If a function is differentiable on some closed interval, it's differentiable on the open interval, I should say. If a function is differentiable on this interval, and if it's continuous on this closed interval, then the mean value theorem formula can start applying. What the mean value theorem says is that, hey, if you find the average slope of the graph between these 2 points, which is the secant slope, right here, makes more sense of the graph. Let's say this is x equals 0, and then x equals 3 somewhere's over here. The secant line is the average rate of change between x equals 0 and x equals 3. Well, the mean value theorem says if those conditions hold that we just talked about, then at some point your function is going to hit that average. Okay, so the mean value theorem can help us find out at what point in time are we moving at an average pace over this interval. Okay, so that's not a super mathy definition, but that's the gist of it. To use the mean value theorem, we need to know the derivative. So this one just involves the power rule. We need to be able to plug in f of b and f of a into the formula. So that means the y value that corresponds with b. So to find that, when x equals 3, y would be, 3 squared is 9, 9 times 4, negative 36. Negative 36 plus 3 makes negative 33. Negative 33 minus 2 makes negative 35. Then when x equals 0, the corresponding y value is going to be negative 2. So this notation says plug c in for x. This notation says plug in the y value when x equals 3. This notation says plug in the y value when x equals 0. And divide that by b minus a, so 3 minus 0. Now it's just an equation, so that's negative 35 minus a negative 2, so negative 33 divided by 3 makes negative 11. Subtract 1 from both sides, so negative 8c equals negative 12, and you know what to do, right? C is going to be 3/2. So when x equals 3/2, the graph has reached an average slope on this interval. So we're given the graph of f(x) on the interval negative 5 to 0. So negative 5 is here on the x-axis, 0 is here. And they gave us the average slope. That's the secant line between the two. Maybe it'd be helpful to know what the slope is. We can't tell. Move the point C so that it satisfies the mean value theorem. Mean value theorem says somewhere between x equals negative 5 and x equals 0, we're going to have the same slope as this red line. Should have something parallel. But without here, maybe, does it cross somewhere? We need to be able to know what the slope is to get this exactly right. Okay, well, this is still an estimate, but at x equals negative 2, we get y equals 2. Let's go down 1, 2, to the right 1. It looks like it has a slope of negative 2. So whatever line I graph, it should also have a slope of negative 2. If I go down 1, 2 to the right 1, that's close. Let's see how accurate. Yeah, okay, they're fine with that. So it's just a rough estimation.